Hey everyone, thanks for joining us. Welcome to this webinar on a system of systems approach for sustainable innovations. This is part 2 of our 3 webinar series. We did a part 1 about a month back. A link of that video will be given to you all at the end of the presentation. And just to let our audience know, a registration link as well as a video link will be available for this webinar as well. So you will be able to view this webinar after it's completed. So just to walk you through on the outline of the webinar, we will have a quick introduction about today's program. And from there, our speaker for the day will talk you to what on a systems of systems approach and how some of the defense programs across the globe, have been using the NAF, the DODAF and the MODAF, application, the DODAF and the MODAF standards, and how it has been being used in the defense industry. A quick introduction about Trident. We are now completing 2 decades of operation in the industry and known as a complete solutions provider. These are some of the clients that we have been working both in the private and the defense sector. We work very closely with Deso Systems. Deso has been a premium partner. We provide a lot of systems engineering solutions, starting from Daimola, which is a complete 1D simulation tool, multi-engineering simulation tool. Then Rectify and Stimulus. Rectify is really for the requirements management and traceability. Stimulus is a very innovative kind of validating your requirements. So a tool which helps you actually debug your requirements, validate your requirements there. Control Build more for designing and verification of your programmable logical controllers or your PLCs. AutoSAR Builder, we have a solution for AutoSAR Builder, and 3D Experience Platform, the flagship product of Deso Systems, which is just more than a PLM and a complete solution for 3D experience. Before I hand over our speaker, let me introduce our speaker today. Himanshu Upadhyay. He's working at Deso Systems as a manager for a technical portfolio. So he majorly works with the systems architecture under the systems engineering. His domain of expertise comes with ModSim, tailoring methods of systems engineering. He also works as a team of cyber systems at Deso Systems. His responsibilities majorly involve developing and demonstrating seamless integrations of system engineering applications. And he's an active member of the international INCOSI and the AppCosi, both in the international and the Asia Pacific forums. So over to you, Himanshu. You can take over.
Yeah, thanks, Sharat, for the introduction. Let me share my screen. So are you guys able to see my screen? Sharat, can you confirm?
Yes, we can see your screen.
Okay. So here we today are having 2 extremely broad topics. One is system of system and another one is sustainability. Okay. So in this session, we will mainly focus on how system of systems approach complements sustainability. Okay. Okay. So with the growing awareness on system engineering, systems are a model in their context. Okay, this particular approach suits when the system context is not evolving very much. So if we take an example of a traffic management system, so basically we have a mixed crowd over here. So I'm taking a neutral kind of an example which somehow affects all of us. Okay, so if we take the example of traffic management system, so it affects all of us, and system has been the context of the system is not evolving very much for centuries. But what about the near future? We will be having multiple new systems that will be coming into the picture. For example, autonomous vehicle. So in order to control them, you will need autonomous law enforcement. And this will in fact make the traffic management system obsolete. So how do we deal with such kind of problems? So if we think from the perspective of deploying the traditional methodologies, so we will be reacting to the evolution of the context and not handling it proactively. Okay. So with the new generation of the cyber physical systems, systems are getting smarter and tightly integrated, which leads to the continuous change in the context of the system, and thereby increasing and in fact dictating each other's design. Okay, so you cannot model a single system which will be getting obsolete in the near future. Today, if we think from the perspective of the sustainable cities, less is more. We would like to have in the near future, we would like to have the noiseless environment, pollutionless environment, as well as the driverless vehicle will be taking over the driver vehicle. The challenges from the sustainability perspective are heavy. Sharat, could you put in the second polling question? Okay. So meanwhile, you guys take the poll. So I move in my presentation. Okay. So let's see the definition of what system of system is. If we focus on the Jamshedi's definition of system of system, what it says is systems of system is constituted of finite number of system which are independent and operatable, network together for a specific period of time. This is quite important, okay, in order to achieve the higher goals. So mostly when I deal with many customers, so in fact, many people are confused, do get confused with the term system of systems. It is mostly used for complicated system rather than the complex system. Okay, so these are the following are the characteristics in order to understand what differentiate. So in order to differentiate between system of system and systems. System of systems are operationally independent. Okay, so even if there is no system of system, they can operate independently. Usually they are managerially independent also. Okay, they could be a part of one system of system, or it could be a part of multiple system of system. And most importantly, they have the independent life cycle. And in fact, they might have conflicting interest in some cases. Okay, and also there is no clear escalation channel. Okay, so here there are few approaches which have been used in the industry as a system engineering methodologies. So first one, in order to model system of systems specifically. So first one is the NATO architecture framework. Next one is TODAF. Another one is UAF. Apart from these, there are other standards as well. For example, MODAF, you have UPDM also, which are used to define the system of systems. Okay. Today we will focus more on UAF, which is the OMG standard, and it is also the emerging ISO standard. So UAF is basically the enterprise architecture. So it consists of two parts. First one is the architecture framework, in which you have the views and the specification organized in the domain and the model kind. Okay, and another one is based on the another aspect of UAF is based on the modeling language and the modeling construct. When I say modeling language, so UAF is basically coming, so it's an evolution of the UML profile and the SysML profile bounded together. Okay, and it's a combination of best practices of the other methods, for example, UAF, DODAF, MODAF, and DNDAF. Okay. So this is how the UAF grid looks like. On the left hand side, you have the different domains. On the in the column section, you have the different parameters. Okay, for wherever they mix, so it is called as a view. Today we will focus only on three specific domain. First one being strategic, another one is operational scenario, third one is system of systems architecture. And from this particular UAF framework, we will see how we can get the requirements for system 1, system 2, and system 3 from the systems of systems perspective. Okay. So let me shift directly to Catia Magic portfolio. Okay, so this is Catia Magic software, and here we will see three mostly used domain from the functional perspective. First one is the strategic perspective, where we will define the enterprise. We will identify the different capabilities. Next domain will be the operational, where we define basically the logical architecture. And the third domain will be the resources. So the resources is nothing but mostly the systems that will be contributing to the system of systems. Okay, so let's move to the strategic domain and let's see what this particular view has for us. So to start with, we start building the enterprise. We define the vision for the system for this particular enterprise. So our vision in this particular case is smooth ground traffic management. Okay, and then we can further elaborate the vision statement. And if we see from the perspective of the traffic management system, so we cannot say directly that, okay, tomorrow we will have the autonomous vehicle. It has to be done in the phase manner. So here we have three different phases for this particular system. So the current phase, which will be basically for a few years. The next phase, which will be having the mixed kind of a vehicle, and this will be the most challenging part. Okay. Then we will have the third phase where we will only deal with the autonomous vehicle. So it has to be done with a timeline. Next, we define the structure of the organization. Okay, so who all are going to contribute to your system of systems? So we identify the different actual organizations who are going to contribute to the system of systems. In this case, we will have manual. When I say manual vehicle, so it's basically the traditional vehicle manufacturer. We will be also involving the law enforcement organization, emergency services organization, and autonomous vehicle manufacturer. And even if we think from the more futuristic aspect, we could also involve low altitude transportation organization, for example, air taxis. Okay, so once we identified the different organization, we identified the different capabilities that will be fulfilling our goals. Okay, so here we identified the different capabilities that are required. One of the example could be the junction traffic management, which is the serious problem right now. And we will be mainly focusing on how junction could be managed with the autonomous vehicle. Okay. Now let's shift to the operational domain where we define the logical architecture. To start defining the logical architecture, we first define the high level taxonomy. So here we will have the emergency services, smart traffic management, and autonomous vehicle. A very high kind of an overview where we specifically where we do not go into the specific, but we define the operational landscape. Okay. Then we define the different operational architecture. Operational architecture is nothing but the constitution of the different operational performer. When I say operational performer, it's basically grouping of different domain. So here, operational performer, we will have the autonomous vehicle, we will have the information and receiver, etc., etc. Okay, so let's go inside one of the operational architecture. So once we have defined the different operational architecture, operational performer, and identified them, so in this particular view, we will showcase that what kind of information is exchanged between the different operational performer, or in other words, we can also say what operational role an autonomous vehicle is going to perform in the operational architecture. So here we define a very high level information exchange. Once we are done with our identification of what are the information exchange, then we can define the different processes on how or what are the different operational activities that are going to be performed by a particular performer operational performer in order to provide some kind of information. Next, we can also define the operational constraint. So in this case, what constraint that we take into consideration is that there is no shoulder lane available, and smart emergency services will be using the autonomous vehicle lanes. There will be separate lanes for manual vehicles and the autonomous vehicle. Okay. And then traceability is another important aspect. So here we define the traceability between the different operational performer and how they will be contributing to the different capabilities. So everything is linked. So the moment you change one thing, you know the impacts of how it is going to impact and which capability is going to impact. Moving further, we move to the logical architecture, or here we define the different systems that will be contributing actually. So here we define the different capability configuration. Okay, if I go inside it, so here so it's kind of a big view. So let me do it like this. So here we have the traffic management system, and then we have the manual vehicle, autonomous vehicle, and smart emergency vehicles. And if you notice, for each resource, we have the state machines. Okay, and inside the state machine, there are behaviors defined. Okay, so we can also simulate it. So basically, it works on the concept of FUML. Okay, so here the concept that we are using is you will have the separate lane for autonomous vehicle as well as manual vehicle. So there will be a stop signal, and we will be mostly focusing on one lane itself in order to reduce the complexity. Okay. So there is a stop signal, there is an autonomous go. So here you can, so when it moves to the second state, so a signal is triggered for the autonomous vehicle to go, and for the autonomous vehicle, they will arrive at the junction, they will wait and register themselves at the junction. So such kind of activity is performed in order to see the complete behavior. So one of the interesting experience I would like to share with you guys is I was talking to Indian OEM, and he said to me that under no circumstances we will let the control of our vehicle uh, uh, to uh, to connect with other systems which are not part of their system of system. Okay, so they don't want to expose any port from the autonomous vehicle. And if we see the difficulty that we will face in incorporating such system after the development, because if someone else who is planning for the traffic management, let's say, in this case, government usually plan for the traffic management system. If both the systems have been developed, and then we have to be reactive rather than proactive in solving such situation. So such kind of uh, problems are usually identified early in the life cycle of the using such methods and approach. So this was kind of a live example that I saw. Okay. So let me shift to simulation part. Okay. So let's try to simulate it. So it takes some time. So I created a video for you guys for such kind of for simulation, so that I can elaborate few cases for you guys. So here, if you see, we will have different systems, and each will be in ideal state at the start. On the left hand side, if you see the panel, it is a simulation panel where we see the parameters, the different parameters that are available for monitoring. Okay, going further a bit. Okay, so here you can see the autonomous vehicle are registering. Okay, so here a signal is getting transferred to the information receiver. Okay, And once the signal is received, it changes its state from idle to nominal data processing. Okay, then it goes further and it changes the state of the different system. So it's a kind of asynchronous modeling that we are doing. Okay, so another way of viewing this particular simulation is we can create a mock-up of the dashboard or a UI kind of a dashboard where we can see the different results, how our scenario is getting completed, where we can also track the different important parameters. So here, just for the test purposes, I developed a random kind of a sampling where the vehicle arrival states. So you will have the manual vehicles which will be arriving one vehicle per 5 seconds, and autonomous vehicle will be arriving one autonomous vehicle will be arriving in 10 seconds. Okay, then we can also track many important parameters such as how many manual vehicles crossed in a single particular signaling cycle, and we can also plot graph which are usually very useful in such cases. And we will also see how we can trigger few emergency situation using the dashboard itself. Okay, so let me play the simulation. So you can see both the signals are red. This is just a visual demonstration of the states. After a few seconds, the queue of the manual vehicle is increased, and you will also have the queues for the autonomous vehicle. Okay, so once we will, so here if we see that the traffic management system was in stop mode, now it is in autonomous queue. So the number of autonomous vehicle will be decreasing. Okay, same is reflected in the graph, and we can see all the 12 vehicles, autonomous vehicle cross the junction. Similarly, when there is a manual go signal, you have the manual vehicle queue which is reducing, and same is getting reflected in the graphs. And there is another view of the simulation where we can validate the different requirements, or we can validate the different capability configuration. We can also perform some qualitative analysis, for example, Monte Carlo kind of analysis, where we can state that, okay, let me check if all the vehicles are getting crossed in about 50 different drive cycles. So here we have a specific requirement that, okay, emergency services shall not exceed 20 seconds to cross the junction. So we will induce artificial emergency, okay, by clicking a button on the dashboard. So here we have induced an artificial emergency, and you could see that all the systems are moving from nominal operation mode to the emergency mode. And in this mode, what we have done is program the system, or the behavior is designed in such a way that no matter what happens, the autonomous vehicle queue will be in green. Okay, they will have the green signal, because if you remember, we have specified in our operational constraint that the emergency services will be using the autonomous vehicle lane. Okay, so you can see the amount of time that is required at the top for crossing the junction. So in this particular case, it was a successful kind of a test. Let's see what happens if it crosses 20. Okay. So in the interest of time, I will forward the video. Okay. So the moment it crossed 20, it is highlighted in pink. So you can validate your requirement not only not only in SysML semantics or the UAF semantics, but it also highlights you, it could also help you in identifying visually. You can also map any kind of important parameters if you want. Okay. From the left hand side simulation panel, we can mark out which particular parameter is affecting. Okay. Then there is another aspect of simulation, okay, where we could monitor the different systems and their states in the graphical manner. Which system was in which state for how much amount of time. Okay, so if we take an example of an autonomous vehicle, it was in start registration stage for about 162 seconds, then registration requests were accepted, and things move like this. And similarly, at the same time, we can track the states of the different systems. So this particular analysis also helps in identifying some contradictory scenario that autonomous vehicle cannot be junction crossing in junction crossing at the same time the manual vehicle are crossing the junction. So such kind of scenarios could be validated using the state machine graphs. Okay. Then we have another way of modeling the similar kind of a scenario. Okay. So we can capture the different, we can capture the sequence diagram while running, or this is sequence diagram is generated live along with the simulation, which could be later used as an information or the test cases for the different system. Okay. And these could be also translated into the requirements, or this could be used as here test vectors, etc. So the complete simulation, so it could be generated for the complete simulation and various kind of information. For example, the timestamp or the time for a particular state is also mentioned, and it works in millisecond. Basically, all the simulation runs on the concept of FUML. Okay, so let me shift back to my presentation. Okay, let's move to the conclusion. Okay. So important thing is we started by definition of the enterprise, where we identified the different organization that will be involved in defining system of systems. Okay, and maybe Sharad, could you launch the second polling question?
Yeah, the second polling question, third one will be launched right now.
Yeah, third one, you can launch the third one. Okay. Okay, so we started by definition of the enterprise, where we define the different organization that will contribute, or where we identified the different capabilities that will realize the goal. Then we also mapped the different actual organization to the different enterprise phases, in which enterprise phase which particular organization will be contributing. Okay, then we move to the operational analysis. Basically, we defined the logical architecture, we identified the different operational performer. Okay, and then we set the context for each operational performer and identified the different operational exchanges or information that is exchanged between the different operational performer. And we also modeled the different activities that needed to be performed in order to generate these information exchanges. Following that, we define the resources layer, where we define actual resources or the systems or the data with the data that is exchanged between the different systems, and also model the different configurations. And we can also generate the test cases for the different systems. Okay, so that's it from my side. I hope I completed in time. So So any questions? So we
Yes,
have, I
Iman.
think,
There are a couple of questions. Just give me a
yeah.
second. First question is, how does
Yeah.
system help in aerospace industry?
Sorry, can you say it again?
How does SysML aerospace industry?
Yeah. So basically here we were talking about more about UAF and modeling system of systems architecture. So there will be two part to my answer. So when you think of an aerospace industry, it is not an independent kind of a industry. So you will be in contact with the different stakeholders. For example, if we take an example of an airplane, okay. So it will be you need to have communication with the air traffic controller. You will need the different meteorological aspect from the weather team, and you will also need to coordinate with the airport also in order to have different enabling system working with you. So such kind of systems could be modeled using SysML or using the UAF profile if we think from the systems perspective. Okay, so SysML is just a language of elaborating the different systems, and it helps to align all the engineers or all the architects at the same page. So when you model something in SysML, the beauty of it is that everyone is on the same page because the notations that SysML provides, it's a graphical language, by the way. So the notations or the semantics that it provides has one explicit kind of a meaning.
Thank you, Iman. We have another question from Rajiv. The question
Okay.
goes like this. Why are we not using Simulink or MATLAB for modeling and simulation?
For modeling and simulink. So MATLAB and Simulink, yes, you can use. So you can model. You can use any kind of a software for modeling the simulation kind of a model. Okay, but those kind of model does come at the solution layer. The analysis that you are doing right now is more of a qualitative analysis. Let me elaborate more on this particular point. So here, let's say if we take an example of your cab booking system or Uber kind of a example. So basically what you will be dealing is, if you are modeling such a kind of a Uber kind of a system. So the most important time will be the uncertainty that you need. Uncertainty will be the most important parameters that you need to consider. What will be the arriving time? Sorry, I need to restart it. What will be the arriving time of the cab for a particular user? So it cannot be beyond certain point. So are you fulfilling it or not for a particular city? So let's say if a cab waiting time is 45 minutes and the fares are too high, you might choose an alternative system to accomplish your goal of traveling. Okay. So such kind of uncertainty analysis could also be performed using FUML. So when we say MATLAB and Simulink, those are good. Okay. Alternatively, we also have the different modeling languages. For example, Modelica based systems. So Daimula is one of them. But basically, it will be used at the system level design or the behavior, or it will be used to model the behavior of the system. You don't need those kind of semantic or very deep kind of a simulation model at the system of systems level. So hence we are using FUML for that.
Right. Thank you, Himanshu. We have another question. The question goes like this. How do we choose between NAF, DODAF, and UAF?
Yeah, so it's an interesting question. So if you see UAF, basically it's a combination of best practices of NAF, DODAF, and MODAF, and it is also getting implemented in the commercial domain as well. So basically, if we think from the NAF and the MODAF or DODAF perspective, these are more defense-centric frameworks. So they will have explicitly more focus on the deployment. Okay. But in case of UAF, you also get the deployment as well as the security aspect. So, and it's also it's also an ISO standard. So I suggest that you start using UAF because it is a combination of all. And it's a work that is being done by the OMG group. So you also have the support of the INCOSAFE for the same.
Right. Thank you so much, Himanshu. We have more questions coming in, but we would like to answer them online, one-to-one.
Okay.
Thank you everyone for joining this webinar. Thank you so much, and have a great day. Bye-bye.
Thank you, guys. Bye-bye.